So, 1/2 plus 1/4. More than, less than, or equal to 1. Less than. Thank you. Less. Now, without doing all the common denominators and all that work, what can help you get to that answer? Maybe more common sense. And when I think of fractions, I always think of pizza now. So, before you learn, do this to the top, do this to the bottom, then you get this, then you change it to improper, then you all these routines. We just added pizza together and slices of pizza. Fraction of 1, each of those. So this is like a half a pizza plus a fourth of pizza. So you have one pizza that has cut into just two halves, one right down the middle, and another one that's cut into 4 pieces. And if you add those together, is that more than one whole pizza or less than one whole pizza?
Less.
It's less. And that's all it is. Right. The fractions multiplying is a little more like area. I always think like a half of inch, quarter of inch, very small. So the area that it will make, because the sides are smaller than 1, okay, the area has to be smaller than 1. Okay? And if we actually solve this, I think we would have like 3/4, right, and 1/8. We multiply 1 times 1 is 1, 2 times 4 is 8. Okay. However, just having this number sense of things are bigger than 1, less than 1. That's very important, because you'll know if your answer, if you get some answer that's wrong, you'll know it doesn't make sense just by saying, what, that answer has to be bigger than 1 because, it's supposed to be making money, not losing money, and my answer came out way too small, that kind of stuff. You do something to go off. Okay, so let's try another. Again, you're writing these down in your notes, or also talking with other people. Keep track of everything.
Equal and then less.
Alright. So I see that you guys have, a lot of you have 1.
Yeah.
So that makes sense. If I had to actually draw the diagrams here. Okay, you have one pizza cut up into 3, another one cut up into 3. So altogether you have 3 slices. That makes 1 whole pizza. Okay, so that's 3 out of 3 slices. Same thing here. We have multiply across, and we have 2 out of 9, so that is definitely less. Let's do a little sidebar here. Let's recall, how do you know just by looking at an improper fraction whether it's bigger than 1 or less than 1? Let's talk about that. So again, I always think about the pizza math. I think we have one pizza here. It has 9 slices, and you eat 2. So the bottom number is always how many slices or what size the slices are. The top is kind of like how much you gave away or how much you ate. So would you say you ate more than a whole pizza or less than a whole pizza? You only had, yeah. So anytime this number is less than the bottom is called the denominator. So you knew the whole thing is less than 1. Okay? Therefore, the whole thing is less than 1. You only ate 2 out of 9 slices. Now, if we look at another example, what would it look like if it was more? So let's just do like, how about 8 out of 7? Well, if there's only 7 slices per pizza and you had 8 of them, that means you had to have a whole pizza. plus one more slice, right? So the number on the top is bigger, okay? Oops. Number on the top is bigger than the denominator. Therefore, it's bigger than 1 overall. More than one pizza. It's amazing how much easier fractions become when you just think about pizzas. Oh yeah, there's only 7 slices, I had 8. Well, I must have had more than one pizza. Okay, that means it's more than 1, it's bigger than 1, that's all. These are not rules you have to memorize and write down and use flashcards. It's just, okay, that makes sense. Alright, so I hope that gives us some sort of starting point of thinking about what you're doing, understanding what it means, not just, well, let's do this at top and bottom and get an answer and move on. One of the questions we'll be asked an awful lot this year that you're not used to is why. So I mentioned before for your quiz tomorrow, I'll have questions, of course, from the homework that are just standard problems, but I might ask you, what's the difference between an expression and an equation? Why do 2 negatives make a positive? Explain to me, you know, mixed number and improper fraction and why they're the same using pizzas. Like writing out and giving me actual solutions, okay, and showing me that what you're thinking, not just, well, I do this to both sides and I get a number and then I do the next one. Okay? Lots of whys, lots of thinking. Well, you can make it up when we get back. Okay. Good. All right, let me throw in a few more things just to cover with fractions. I'm not going to assume anything right now. I want to give everybody a good background just to make sure. So, how about 2 plus 5 and 1/3? Two plus 5 and 1/3. Go ahead and solve that, maybe by yourself or with someone next to you. See what you guys get. Give it a go. Help each other out. So, some of you would look at this, right? And some of you would look at this and go into autopilot, which can be good or bad, and you just start doing the normal thing, well, I gotta convert this to an improper, then I gotta put this over 1, then I gotta do common denominator. But remember, when we first started fractions, they're actually a lot easier. It was just pizzas. All right, I have 2 whole pizzas, and I have 5 more, right? And then I have 1/3 of 1 pizza. How much pizza here do I have? 7 1/3 pizzas. Yeah, that's it. Right? Right? Now, how about how many slices? If they all had to be slices of 3, how many slices are there altogether? So if these are all slices and thirds, how many slices total?
A lot.
22 slices of 3. You just converted the mixed number to improper. That's all. That's the only difference. Okay?
Yep.
So you see, well, here's what I observed year after year. How is that person that's doing the quiz so much faster? Looks like they're writing less, and it looks super easy to them, and they're getting 100%. Right? It's not necessarily always they just do it faster. They just know how to something I'm doing, but they just do it like that, and they just have this power because they're just good at math, and all these other myths we make up because it just seems like that's the easiest thing to believe. You can't believe that they're just doing something slightly different that's the easier way. We make up these fantastic stories like, oh, they're just a math person, so they just get it. all that junk. That is not true, but tell yourself to make you feel like, well, okay, it's not really my fault. There's something I can do. When really, maybe you're doing all this common denominator business. The person next to you that's getting it right really fast, they're counting pizzas. It's not, it's not like they're doing something super hard but faster than you, and that's why they're so good at math. If you're looking at it like, well, that's an easier problem than I might be thinking, and that's why they're getting it faster. I understand that I've done this before, actually, because I have some friends that teach elementary. I've actually had friends in elementary give this problem to the second grade, third grade kids. They almost all get it right. Because this is what they know, that's all they know, and that's what they do, and it's easy. And we do it here, and we get so consumed with, well, you have to do this, and you have to do this, and all this, and you forget that it's just pizzas. You don't have to do all that. Sometimes you do, but when you come across some problems, it's not all about just step 1, step 2, step 3, and let's get lost somewhere along the way. Okay? It's pizza, man. It's almost fun. Alright. Same thing here. Let's try something similar.
Multiply the 3, we get 21, and add the 1, and get 22.
Same thing, right? That's what it is. Alright, try this one. 6 minus 1/4. Don't go into autopilot and do common denominators. Just think. You have 6 pizzas. You have 1 slice. That's a quarter of a pizza. What's left over?
0.25.
Well, in brackets. Give it a sec. Like 30 seconds. See if you guys can figure out between you and your neighbor. Go. Not right now. Almost done. You should be doing this right now. Right now. No. Okay. And we're back. So once again, before we get caught up in too much stuff, okay, I need to know that the denominator tells me how many slices each pizza has. So 4 slices for every pizza. It's always the same for every pizza. That's what the common denominator is about. It's in common with all of them. So, and I eat 1. What's left over? 5 and 3/4. Yeah, we don't have to go through all this headaches of common denominators. Alright. Now this works when you're adding, subtracting, and one of them is just a whole number. Good. Anything else? I think we're about the same. Okay, my last point is going to be just common denominators in a sense. So we have 2 pizzas, one's cut in half, one's cut in 4ths. Alright. And I want you to say that this one is, and this one is. This would be like a half, this would be like a 4th. Okay. How come we cannot just add these up and say, there's 2 and then, 4ths or something like that? Why? Loud so everybody can hear?
There's not that many slices.
Yeah, well, right. So what this tells us, here's the common denominator thing, is that, okay, yeah, we have 2 slices, that's correct, but they're not size 4. They're not the same size. That's the problem with fractions that don't have the same denominator. It's assumed when you're talking about I have this many slices, like when you get it from wherever you get your pizza, they should be basically the same size. And we can't count how many slices you have unless they're all the same size. So what we do is we do something to make them the same size. If I make another cut, okay, there's twice as many slices now. There are smaller slices, but there's twice as many. So, but now they're all equal size. And now I can actually count out how many there are. So I made a cut. They're all twice as small, really. The slices are now smaller. Right? Now I know I have 2 out of the 4, and here I still have 1 out of the 4. And now I know total I have 3/4, 3 slices, 3 even slices when the sizes are size 4. That's a common denominator. That's why we multiply the top and bottom. Okay, it all should make sense, not just, well, how come you multiply the top and bottom? I don't understand. It's not going to fly. That's not going to work. That's not going to get you out of algebra 1 if you just say, well, you just do because that gets you an answer. Doesn't get you by the first quiz. You got to know why. You got to explain why in words. Good. All right, so let's look at a little bit on our homework using all this review and do a few of these together. So let's start with the first one. Here we go. So we can see we still have the algebra. The only algebra here is the plus and negative. You have to know what that means. So if you prefer, you can change it to minus that. Notice how I moved the negative here to the top. That's very useful because otherwise you can look at this and say, oh, that's 6/2. When you move the negative up here, oh, it's -3. Okay, that's actually 0/2. 0/2 is 0/2. 0 divided by 2. If you have 0 slices, how much do you have? 0. Nothing, right? Take away half, so our answer is just -1/2. Yeah. If we have 0 slices, regardless of what size the slices are, you have 0 slices of pizza, so you have nothing. 0. There you go. Here's a good example of what we just talked about in number 3. That before, you see how there's a whole number here. So it's a simpler problem. Okay? It's like the pizza math. You have one whole pizza. It's cut into 7 slices. Looks like you're subtracting, so that means you're eating 6 of them. What's left over? Yeah, one of those slices is left over. 8, 6, so there must be 1 left over because it's cut into 7s, right? Don't need to do the common denominators or any of that stuff. Alright, go to here. So here's where we start having a need to do a little bit more. A couple ways of looking at it. We have 7 pizzas, half a pizza, another whole pizza, and then 4/7 of a pizza. So we could figure out how many slices this is, and do, what would that be? 2 times 7 plus 1, 15. Okay, so this has 15 slices, each a half of the pizza. And over here we have, let's see, we have 11 slices, but they're each 7. They're only 7 slices in this pizza. Much smaller pieces, right? So if 7 in one pizza, they're smaller slices. But we can't add these up because they're different size slices. So we have to figure out, well, we cut these halves, and make those 7s. And we take these and we cut those in half. Take all those small slices, cut them even smaller. Now they're all size of 14. Now they're all 14 slices in each of them. And we can count out how much there are because they're all the same size now. 7 times 15? 105. Okay. And 11 times 2? Add it all up. 127. Yeah. A lot of slices. Now, question? All right. Well, we can look at it let's see if we get the same answer. I'm going to show you another way. If we just kind of drew this out, again, maybe this is something you want to do just for now, but later on you won't need to. 6, 7, and then this is a half. And then we have 1 here, and then this is like, what, 4/7? Just kind of sketch it barely like this. Let's say that's 4/7. We already know we have 1, 2, 3, 4, 5, 6, 7, and then over here 8 whole pizzas. And then we just have these 2 fractions of a pizza. So another way of looking at this is, why don't we just add the 2 whole numbers together and get 8, and then just figure out what 1/2 plus 4/7 is. Maybe this is a lot easier than all these numbers that are a lot bigger. Okay. This is what we're doing. We're using the commutative property. We're kind of changing the order of which we're adding. Instead of adding 7 plus 1/2 plus 1 plus 4/7, I'm just going to add the whole numbers together and then add the fractions together. And when you go about this way, the numbers are a little bit smaller. You can still see we're going to use the same common denominator numbers here, right? And get 7/14 and 16/14. 4 times 4? 16? Oh, we're okay? Help me. Help me.
Hey, the other one is
Yeah.
use 2.
Oh, I should be using 2. Very good. Thank you. Yeah, very good. So yeah, 2/2. Same numbers. Same numbers. Very good. And then add 8 over. So that's 15 slices. So now I have 8 15/14ths. Right? Which you could say, well, this is more than a whole pizza, right? So that's 9 and 1/14. All comes out the same. These two are actually the same thing. This says I have 127 slices. If we use the size of 14, this says I have 9 whole pizzas, which is true, with 1 left over. Either way, works out the same. I want you to investigate and play with both. Now, the adding subtracting is always the one that's a little more problem because of the common denominator. Once you get down here, you have to multiplying. You have 2 options. You can multiply and cross. 8 times 5 is 40, and multiply across here, and then divide. Right? And get 8/3. Or you can cross cancel and say, well, on the diagonal or up and down, vertically or diagonally, you can cross cancel. What we're doing here is we're doing 5 divided by 5, which equals 1. So when they cancel out, make sure it's a 1. It's not 0. 1 times 8, 3 times 1. Same answer. This cross-canceling is probably the better way to go, because sometimes these numbers are so big you can't figure out what goes into it evenly. Much easier if you just cancel it out without multiplying. All right. Lastly, dividing. In short, is there any difference between taking half of something and dividing something by 2? Think about it. $10. Take half of that. All right. $10. Divide that by 2. Taking half, dividing by 2 is the same thing. That's why we do this. Okay, you flip and multiply. Because it's the same thing. Well, dividing by 2, $10 divided by 2 is $5. Taking half of $10, same thing. It's actually the same thing. It's not a rule that makes the problem work all of a sudden. We're just asking the same question in a different way. For homework, let's just finish up the front. Okay. The back will finish up. You can start it if you like. If you have the time you want to do it, go for it. You're going to have to do the whole thing eventually anyway. But for tomorrow, I'm just going to check the front. But I want you guys to make sure you're doing the front correct before we flip it over and start doing equations. Because if we're not doing the front correct, the back's not going to be pretty. Okay? So, and tomorrow's Friday. Yay.